Okay, Assalamualaikum and hi to all. So for today, let's continue our chapter 2. Okay, from what we have read from previous topic. All right. So previously we have learned about Coulomb's law. All right. So I am hoping that you are still remember some of the uh, some of the uh, some of the formula, which is force, okay, where the force is equals to Q1 Q2 over 4 pi epsilon naught r squared, which is r, the distance from 1 and 2, and the vector of a hat, which is vector 1, vector r1 until 2. Okay, and epsilon naught is the permittivity, okay, the value of permittivity, okay, which is epsilon 0, epsilon naught 8.854 times 10 to the power of minus 12. By right, I know I should but I hope that you already find the the unit for this permittivity, which is force per meter. All right, so this is just a revision from previous one. All right, so let's continue. All right, let's continue, which is electric field due to continuous charge distribution. Okay, so let's assume, okay, let's think that we have a point charge, which is Q1, and same as before, we want to find this uh, field, okay, electric field related to this point charge at this position. And if you still remember, as I mentioned before, this field, okay, can't be seen, and in order for us to define it, we assuming that there is another Q here, okay, there is another point charge here, which is can be written as QT. Okay, let's name it as Q. This QT, we know that there is a force, okay, between these two. Okay, there is a force between these two. Okay, where the direction is here. Okay, so these are the force Ft. So this force, this force exerted on xt is due, okay, this force exists is due to x1. Okay, this force can't be exist if there is no q1. So qt will not experience, qt will not experience any force if there is no q1. All right, so there must be something that q1 do in order to generate force at qt. Okay, there must be something that q1 do, all right, in order for force to be applied at qt. Okay, all right, so now this is something, okay, this is something we do not know what is q1 emit, what is q1 produce in order to what to form this force. We don't know anything, but we know something has been done, okay, in order to form a force at qt, which is from q1, right? So this something, okay, this something which must be exit, it is known as, okay, it is known as, this is something, it is known as electric, it is known as electric field density. Okay, it is known as electric field density, where it can be represented as E, and since that it has a direction which is towards QT, so it is a vector form. Okay, so how to define this ET? So we need to define this ET. Okay, in order to define ET can be defined by EP, which is a form of vector, can be defined by force of QT okay, over magnitude LEQT. Okay, so I think force we have learned before, which is from this formula we have learned from previous class. So force is equals to, let's say, in this case, Q1 QT, all right, Q1 QT over 4 pi epsilon newt R epsilon naught, sorry, R1 1t, in this case, yeah, 1t squared, and then the direction of E hat, distance 1, point charge 1 until point charge t, and this is over QT. Okay, so mathematical wise, this can be simplified by, this can be simplified where this QT can be eliminated, right? Where it leaves to us only this. So it means that ET can be right as E, yeah? Let's make it formal, okay? Instead of ET, I make it like I formalize it as E, all right? E is equals to Q over 4 pi epsilon naught R, which is the distance between two objects, squared E R vector. Okay, so these are the formula, or this can be defined of electric field density. All right, so now, okay, I hope this is clear. All right, I hope this is clear how that it can comes to this. All right, so now let's discuss, or let's think of 1 point charge. Okay, let's think of 1 point charge, and that, which is the same as this. Okay, now let's think of another point charge, which is Q1, and we want to find the electric field at this position. Okay, at this position, and then same as before, assume that there is, because a straight line. I'm so sorry, my line is not straight. Okay, bring it to there, where the electric field direction is of this. This is E1. Okay, so in this case, all right, in this case, all this while we have discussing if the point source, the point charge source is only 1. How if there's lots of point charge? For example, we have Q1, we have Q2, we have Q3. How it will be? Okay, so now let's think of that. All right, so let's say that we have another point charge, which is Q2, and the electric field same as Q1, which is located at here. So what we're going to do is we'll make it another line direction and make it where this is the direction of E2. Okay, so let's think that we have another point charge, which is this one. Okay, let's say that another point charge. Let's say that it is Q3 now. And this point charge, we want to find the electric field at the same position as Q1 and Q2, which is here. And we make another line where now the E is pointing at here, which is E3. Okay, now, all right, so this is different with before. Okay, this is not continuous. Okay, this is different with line charge distribution. Okay, this is different with line charge or surface charge or volume charge. Okay, where surface line charge, all the point charge, it is a continuous, it is a form of continuous point charge, lots of point charge together to form line charge. However, in this case, this is a discrete. It is separate. Q1 is not continuous with Q2. It is not continuous with Q3. We call this as discrete. Okay, we call this discrete point charge. Okay, discrete point charge. All right. So in order, I think mathematical wise, in order for us to find the total electric field, so what we can do is, okay, in order for us to find the electric field of this discrete of different point charge at this particular location, what we have to do is the total of electric field is, so mathematical wise, I think all of you know how to find it, which is E1 plus E2 plus E3, right? So we can use sigma here. Okay, sigma, where I is start from 1. Okay, I start from 1 up until 3 here. Okay, up until 3. So Qi over 4 pi epsilon naught Ri squared Ari direction. Okay, so mathematical wise, if it is a discrete, in order to find the total electric field, we need to sum all of these 3 points. How if we want to find electric field if it is a continuous charge, for example, line charge, surface charge, or volume charge, how it will be? Okay, now let's look at that. Okay, so continuous charge distribution. All right, so in your textbook, I think you can find, if you have already bought or if you have already get this Sadiko Essential of Electromagnetics, thank you very much. I think this book is really helpful. It helps you to understand well for this EMT. So for those who already have this book, you can turn from page 113 to 134. Okay, 113 to 134, and you can, I think, if you read that books or you refer to that books, you're gonna be much understand. Okay, you can deepen your understanding in EMT. All right, so let's discuss how about the electric field in line continuous charge distribution. So first of all, let's discuss in line charge conditions. All right, so let's say that we have a line. Let's say that we have a line, and we want to find the total electric field for this line. Okay, what we have to do is, okay, first of all, we need to identify what are the information that we can get from this line. Okay, so first of all, we know that this line has a total length. The total length of this line is L. Okay, the total length of this line is L. And let's say that we want to find the electric field at this point. Okay, electric field at this point. And so same as before, what we have to do is we have to make a sample. Okay, we have to make a sample where anywhere in this line. Okay, a sample anywhere in this line. For example, let's take a sample at this point. So same as before, the sample for this at this line here, at this point, it carries a small amount of from the total charge, which can be represented as dq. Okay, so this dq to this electric field, okay, will produce dE, small amount of electric field for this dq. right? So let's say that we are taking another point from this line, okay, still from this line. Okay, let's say that we are taking from this line at this point, all right? So it same as before, it produces of dq, small amount of this dq, and our particular electric field is same, which is here. So make a line, connect to here. So this will produce amount of dE, which is respect to this sample. Okay, let's say that we have taken, let's say that we take another point, another sample, which is at this location. Okay, and it's towards this electric field as well. And so this is also carry dq, and this also will carry from this particular, where it also have a small amount of electric field, which is dE. So how to find? Okay, so this sample, yeah, is actually a duplicating of one sample. Okay, so this sample is actually duplicating this sample, but however, what is the difference is? The difference is at different position. However, the position is still on the same line. Okay, still on the same line, and same as this sample too. Okay, so anywhere, as long as the sample is located at the same line charge, it is like a duplicating the same point charge, right? So in order to find the total E for this structure, for this line charge, for this particular line charge, so we can, since that it is continuous, we can say the total charge of this structure, it is actually an integral, right? Instead of sum, it is actually an integral. Why it is integral? Because it is a continuous. So that's why also in previous, in last topic, we still using the integral, right? If you still remember, in order to find the force, okay, we are using the integral as well. Okay, so why we are using the same integral? Because it is a continuous, right? It is a continuous. All right, so now, so since that it is continuous, so we are using integral. So the formula is same, okay, which is dq. Okay, this formula is same with this one. Okay, same with this, but the difference is only instead of q, we are using dq, right? So we are using dq over, okay, dq over 4 pi epsilon naught r squared and ar hat. Okay, so dq now, what is the value of dq? The value of dq same with the one that we have discussed before. It is rho L dl. Okay, all right. So how about surface? How about surface? Same goes to surface. Okay, same goes for surface charge as well. So in order to find the total E, okay, it is double integral. Okay, double integral. So it will be dq over 4 pi epsilon naught r squared ar hat. Okay, but now the dq is referring to rho s ds. All right. Next, for number 3, same goes to number 3, which is a volume charge. Okay, volume charge, where the total E will be electric field density, will be triple integration. Okay, it will be triple integration, or sorry. Okay, so it will be dq over 4 pi Q over 4 pi epsilon naught R squared ER cat. So now the dq is, if you still remember, what is the value of dq for volume? So it will be rho V over dV. All right. So yeah, so this is how it will be, okay, for line charge, surface charge, and volume charge. But for point charge, it will be discrete, so it will be like this. All right, so I really hope that you got the idea. So this is how it will be.